Section 7.2a is trigonometric integrals, and you're going to be using trig identities to make substitutions before you do the integration. So your trigonometry is going to come in really handy. If you're not very good at trigonometry, you need to go pull out those identities and practice. Remember those verify in chapter 5 of trigonometry? Yeah, that's what a lot of these problems look like. So some of the more common ones are, I would make notes of these. Sine of 2x equals 2 sine x cosine x. We use this one a ton. Cosine of 2x. It has 3 possibilities, so you're going to pay attention to, we have cosine squared x minus sine squared x, or it could be 2 cosine squared x minus 1, or you could use 1 minus 2 sine squared x. 2 more that are really important, sine squared x. You can't just integrate sine squared x because it's parentheses sine x squared. So we use 1/2 parentheses 1 minus cosine 2x. Now, if you look at a trig book, they're going to call it 1 minus cosine 2x all over 2. The parentheses form that we have here is a little easier. And then cosine of squared x is 1/2 1 plus cosine 2x. Those are the identities that I would say they're used the most in these sections. You should also know that sine squared x plus cosine squared x equals 1. And manipulations of that, what I mean is 1 minus cosine squared is sine, and sine squared x equals 1 minus, I just said that, 1 minus cosine squared x, and cosine squared x is 1 minus sine squared. So these are your most common. You should know that if you have 1 over sine of x, this equals cosecant x, and 1 over cosine x is secant x. The way to remember that is the front letters don't match. So if you struggle with that, that might be helpful. 1 over tangent x equals cotangent x. So these are your basic trigonometric functions that you need to keep in mind. They're going to come in handy. There may be others. There's a reference on the card if you have a paper book. I don't know that you do. But there are some reference sheets you can find and print out. So let's look at a couple problems. So we're going to start with the integration of cosine to the third x dx. This is example 1 in your book. You can't use substitution because this is basically saying the integration of cosine of x to the third power dx. So if you let u be cosine of x, then think about it. du is negative sine x, and that's not in the problem. So what we're going to use is we're going to make some trig substitutions based on identities. So let's rewrite it. I know that cosine to the third is cosine of x multiplied by itself 3 times. So let's call it cosine squared x times cosine x dx. Now, we just talked about using cosine squared. Did you make a note of that? So we can go back and look at our options for cosine squared. Cosine squared, we could be using something like this and solve it for cosine squared. Not highly recommended. A lot of times this is going to be what we use. So we're going to use the form of this to say cosine squared x equals 1 minus sine squared x. And that's going to be the one that helps us the most. So let's put that in here. We're going to say the integration of 1 minus sine squared x times cosine x dx. Have you heard that Calc 2 is the hardest in the calc sequence? It's because all the problems start off with an integration in terms of a variable. And you have to know, you have to look at them and know which method you're supposed to be using. So be careful with that. All right, so now that we have this, I would distribute this to be cosine of x dx. And then you have minus the integration of sine squared x cosine x dx. The reason I distribute is because sometimes, first of all, do you see u sub is going to happen on the second integral? It doesn't always happen on both. In this case, you would be okay, but it's something you need to consider. So we're going to let u here equal sine x because we have sine squared. Hopefully you see that composite function. And du is cosine. The derivative of sine is cosine x dx. So dx equals 1 over cosine x du. So the integration of cosine of x, we're going to start on the left. The integration of cosine is positive sine x minus the integration of u squared times cosine x times 1 over cosine x du. So our cosines cancel nicely. So we have sine x minus the integration of u squared du. The integration of u squared is 1/3 u to the third plus c. So this means we have sine x minus 1/3, and u is sine to the third x plus c. And that would be your answer. So your goal is to start out here and make trigonometric substitutions so that it gets into a form that you can integrate. Let's look at another one. This one says the integration of sine to the fifth x cosine squared x dx. We have options. If we go back to that first slide again, we're still looking at the squareds. So we can solve like we did before for cosine squared, or we could solve for sine squared equals 1 minus cosine squared x. So one of those two is going to be nice, but the question most people ask is which one? Like in the previous problem, here I have a cosine, so I needed my u to be sine so that my du is cosine and that will cancel. That's where you're going to see it help you the most. So you have to think about the fact that when I look at this problem, I see a sine to the fourth x times the sine x. Here I have a singular sine. That makes sine to the fifth times cosine squared x. So I want this to be my derivative. Whatever u is, I want that to be du. So that's your hint here. Whenever you have an odd power, that's the one you want to change. You're going to keep a single one to be your du, kind of, and you'll see it cancel out. For example, over here, notice how these cosines canceled out down in here? Because my du was cosine x, so my cosines canceled out. That's the concept that I'm heading for. So I'm planning to let u be cosine, so that our du will be this standalone sine x. So that means we've got to change this first term in terms of cosine. Now remember, back to the first slide, we know that sine squared of x equals 1 minus cosine squared x. And that's something you need to be comfortable with solving regularly. So we're going to have the integration of, now sine to the fourth really means sine squared of x squared. Do you know this? That means I'm going to replace this to be, let me put that line back in for you. This is sine squared x squared times sine x times cosine squared x dx. So now we're going to make that substitution, 1 minus cosine squared x squared times sine x times cosine squared x dx. Now we generally like our cosines to be together. We could switch it. It doesn't really matter. 1 minus cosine squared x times cosine squared x sine x dx. So we're going to let you, oh, there's a squared on there. Don't forget that squared. That's important. You could do FOIL, but it's a lot easier once we make our u substitution. So let's let u equal cosine x. Then the derivative of u, the derivative of cosine is negative sine x dx. So dx equals negative 1 over sine x du. So we have the integration of 1 minus u squared squared, and then cosine squared is u squared times sine x times negative 1 over sine x du. Now this negative 1 we can move out to the front, so we have technically a 1 still on top there, and these sine x's cancel. So we have negative integration of 1 minus u squared squared du. So u sub would be messy to do again. Let's just expand this. Remember that when you expand a binomial, you should write it twice and do FOIL. So that means we have negative 1 minus 2u squared plus u to the 4th u squared du. And then we don't have the product rule. Well, you could do integration by parts, but this isn't that bad to distribute. So let's put u squared minus 2u to the 4th plus u to the 6th du. Now notice the parentheses around all of that. That's because the integral starts at the top and moves all the way across. So you've got to have, that's why the parentheses go here around all of that, because the integrand applies to all of it. So now we can integrate, and we have 1/3 u to the 3rd minus 2/5 u to the 5th plus 1/6 u to the 6th. 1/7. Let's try that again. This last phrase becomes 1/7 u to the 7th plus c. So we have negative 1/3. And remember our u, go back over here, our u is cosine x. So we have cosine to the 3rd x plus 2/5 cosine to the 5th x minus 1/7 cosine to the 7th x plus c. So you can see that we distributed the negative as well as put the x value back in. So here's the key. You've got to make a trig substitution back here, and that's what this whole unit is about, this whole lesson. It's about the fact that you need a trig substitution back at the beginning, or you cannot integrate. So now we're going to look, and the problem says the integral from 0 to pi sine squared x dx. And you look at me and say, there's no u sub here, because if I let u be sine x, then du would be cosine x, and it's not in the problem, so you can't do that. So think back to the first page. Please tell me you wrote those down. We're going to be using this one here, the 1/2. We tend to use the 1/2 parentheses 1 minus cosine 2x. So let's make that substitution. The integration from 0 to pi, 1/2 parentheses 1 minus cosine 2x dx. So let's distribute the 1/2. So we have the integration from 0 to pi, 1/2 minus 1/2 cosine 2x dx. Now you can integrate cosine, but you can't integrate cosine of 2x. You can only integrate cosine of x. So we're going to need u sub in the second term, but not in the first term. So let's break it into two integrands. So we have 0 to pi, the integration of 1/2 dx, minus, I'm going to pull the 1/2 out integration cosine 2x dx. So we're going to have to use u sub here. We're going to let u equal 2x. So think it through. So du equals 2 dx. So dx equals 1/2 du. So we've got the integration. Oh, let's go ahead and integrate that. The integration of 1/2 is 1/2 x from 0 to pi minus 1/2 the integration of cosine of u times 1/2 du. So those two 1/2s make 1/4. So we have 1/2 x from 0 to pi minus 1/4 the integration of cosine of u du. So we have 1/2 x. I'm going to go ahead and put 1 parentheses minus 1/4. The integration of cosine of u is sine of u from 0 to pi. Some of you change bounds. That's okay. Just be careful on the terms that you do and the terms that you don't. Minus 1/4, and then sine of u is 2x from back over here. Sine of 2x from 0 to pi. So now we're ready to evaluate. I have 1/2 times pi minus 1/4 sine 2 pi minus, and I have 1/2 times 0 is 0, minus 1/4 sine of 0. Now sine of 0 is 0, so we're good there. And sine of 2 pi is 0. Remember your sine graph goes like this. So here's 2 pi and 0, and pi is in the middle. So we have 1/2 pi minus 0 leaves us with pi over 2 for our final answer. So let's consider the integration of sine to the 4th x dx. So very similarly, we can call this sine squared x squared, right? Let's make the same substitution. So we have 1/2, I used a bracket, 1 minus cosine 2x dx. And this is an interesting problem. This is squared. This whole thing is squared here. So 1/2 squared is 1/4. That's the easy part. 1/4. And then we're going to square 1 minus cosine 2x. So we get 1. Remember, write it twice and do FOIL. 2 cosine 2x plus cosine squared 2x. Well, that's just a mess. Think about this cosine squared of 2x. So let's say that cosine, well, that's not working. Cosine squared x we know is 1/2 1 plus cosine 2x. So with that in mind, if we have cosine squared of 2x, this is going to be 1/2 1 plus cosine of 2 times 2x, because the 2x goes in there. So that means cosine squared of 2x equals 1/2 1 plus cosine of 4x. Do you understand that substitution? Because if not, you need to go back and think about it again. So let's keep going. We have the integration of 1/4. We're going to put that in. 1 minus 2 cosine 2x plus 1/2 times 1 plus cosine 4x dx. Well, let's distribute that 1/2. We have 1/4, 1 minus 2 cosine 2x plus 1/2 plus 1/2 cosine 4x dx. Combine like terms. Some of you don't do that. You just carry crazy long integrals. Let's combine like terms. So 1 plus 1/2 is 3/2 minus 2 cosine 2x plus 1/2 cosine 4x dx. Now we're going to have to use u sub. We're going to have to use u sub twice. We're going to have to use u sub on this 2x here and on this 4x here. So let's go ahead and split these into 3 integrals. So we have the integration of 3 over 8 dx minus 1/4 times 2 is 1/2 cosine of 2x dx plus 1/4 times 1/2 is 1/8 cosine of 4x dx. Now, I don't like to use u sub twice. I don't like to use u's because they look like they're the same u. So let's let u equal 2x here. So du is 2 dx. So dx is 1/2 du. And over here, let's let m equal 4x. M tends to be my second u sub letter. So dm equals 4 dx. So dx equals 1 over 4 dm. All right, so let's rewrite this. Let's go ahead and integrate 3 over 8 dx. That gives me 3 over 8x minus the integration of 1/2 cosine of u times 1/2 du plus the integration of 1/8 cosine of m times 1/4 dm. So we have 3 over 8x minus, I like to clean it up. We have 1/4 cosine of u du plus the integration of 1 over 32 cosine of m dm. So we have 3 over 8x minus 1 over 4, and the integration of cosine is sine of u plus 1 over 32, and the integration of cosine is sine of m plus c. So now we need to go back. We have 1/4 sine of u is 2x plus 1 over 32. Sine of m is 4x plus c. So it's not that bad. It just, you have to be careful all along the way. Now, this is from your book. It's a strategy for integrating. And the people who memorize well, memorize it and then forget it, and you're going to need it long term. So I think you're better to think. So they're telling you that if cosine is odd, then you're going to keep a cosine out and put everything in terms of sine. And if sine is odd, you're going to keep the sine out and get everything in terms of cosine. And if you have matching powers of even and odd, if they're both even, then you're going to use half angle identities. We talked about watching for that pattern and using it. That's probably your best bet. It's always better to think through math than to try to memorize. The problem with memorizing is you may have it now, most people don't remember it later. This is an interesting identity down here. It's the same identity we talked about in the first slide, where sine 2x equals 2 sine x cosine x. The difference is they divided the 2 to the other side. So sine x cosine x, and you move the 2 to the other side as a 1/2 sine 2x. So it's nothing profound. You're truly better to think through math than to try to memorize it. So another function that you need to make a note of is that secant squared x equals 1 plus tangent squared x. I forgot to state that one on the first slide. So let's look at one of those. Let's save it for the next video because I only have about 5 minutes left here. So thank you.